Good afternoon, everybody. Welcome to the course on Principles and Practices of Process Equipment and Plant Design. Today we will be discussing week 6 previous year assignment questions. Myself Suraj P from Chemical Engineering Department, IIT Kharagpur. So let us go to the first question. In first question, it was asked, choose the correct statement about the weep holes. Four options are there. First option, correctly sized weep holes do not allow vapor passage during operation. Second option, weep holes are required for draining out excess liquid from the tower while operation. Third option, required only in the active area of the tray. And fourth option is essential in sieve and valve trays. So the correct answer, we know that the weep holes are required weep holes are required for not allowing the passage of vapor during operation. So let us see the detailed solution. And a correctly sized weep hole should not allow vapor passage during the operation, and if liquid passage happens, it is called as weeping. So and the weep holes are present in both active area and downcomer area. So option C is also wrong. Option D, weep holes are mainly present in sieve trays and not in valve trays. So option D is also wrong. So let us see option B. Option B, it's written required for draining excess liquid from tower while in operation. So the weep holes are required for draining the excess liquid when the plant is in shutdown. So the column will be in shutdown mode, and if we need to drain out the liquid from the tray, we will use help of weep hole. So the weep holes are required for draining out liquids from tray after the tower operation shut down. And weep holes should not weep during operation. And the weeping condition happens when the flow rate of the vapor is low and the liquid flow rate is very high. And weep holes are mainly provided on all block portion of the deck that does not drain naturally. It is also provided in downcomer area and active area. So the correct answer for this question is option A. A correctly sized weep holes do not allow vapor passage during operation. So next question, which of following characteristic is undesirable for packing material in a packed bed tower? Options are low weight per unit volume, large surface per unit volume, large liquid hold up, large void volume. So we know that there are some desirable characteristic of packing material in a packed bed tower. One is that it should have low weight per unit volume. So option A is a desirable property. And let's see option B. The packing material should have large surface per unit volume. It's also correct. And option C is wrong, because the packing material should have low liquid hold up. If the liquid hold up is high, then the gas flow path will be constricted and there will be a high pressure drop in the column, which is undesirable. So the undesirable property of a packing material is large liquid hold up. Option D, large void volume. So large void volume is a desirable characteristic of packing material. So the option C is correct. uh, Large liquid holdup is a undesirable characteristic of packing material in packed bed tower. So let's see what are the main characteristic of packing material in a packed bed tower. First one is low weight per unit volume. Second one is large surface per unit volume. Third one is low liquid holdup, and the fourth one is large void volume. Let's move to question number 3. Choose the correct statement among the following. Here some statements about tray column and packed column are given. First statement is packed towers are preferred over tray tower for handling corrosive and foamy liquids. Option B, tray column can handle higher liquid holdup without flooding compared to packed column. Option C, tray tower is preferred over packed tower if the operation involves liquids containing dispersed solid. Option D, all of the above. So packed. So let's see the option. They are asking which one is the correct. Packed towers are preferred over tray towers for handling corrosive and foamy liquids. So option A is partially correct, as packed tower is preferred for handling corrosive liquids, corrosive fluids, but it cannot handle foamy liquids. Foamy liquids are mainly handled using tray column. So option A is incorrect. Option B, tray column can handle higher liquid higher liquid load without flooding compared to packed column. Option B, tray column can handle greater liquid loads without flooding compared to packed column, but there's a condition that the flooding is decided by the vapor load for a given liquid load. So if to prevent flooding, the vapor load should be higher than liquid load. So option B is also incorrect. So let's see option C. Tray tower is preferred over packed tower if operation involve liquid containing dispersed solid. So option C is correct, because tray tower is preferred over packed tower if operation involve liquid containing dispersed solids. This is because fine solids quickly clog in the pores of the packed bed. If they clog in the pores of the packed bed, then there will be increase in the pressure drop in the inlet and the outlet of the packed tower. This will lead to excess load on the upstream pumps and compressors. So option C is the correct statement, because tray tower is preferred over packed tower when the operation involves liquid containing dispersed solids. So let's see. Packed tower are preferred over tray towers for handling corrosive. So this is true. Then tray towers are preferred for foamy liquids. Then tray columns can handle greater liquid loads without flooding compared to packed column, but flooding is decided by vapor load for a given liquid load. And tray tower is preferred over packed tower if the operation involves liquids containing dispersed solids, because the fine solids quickly clog the packed bed pores, leading to increased pressure drop. So let's move to question number 4. The factors to be considered in the selection of packing material for a gas absorption column is 3 factors are given: size of the packing material, durability of the packing material, porosity of the packing material. So we know that all these factors is to be considered for selecting a good packing material for gas absorption column. So option D, all of the above, is the correct answer. Along with this, cost should also be considered for selecting a desired packing material for gas absorption. Next one, when adsorption hysteresis is observed, the desorption equilibrium pressure is dash than obtained by adsorption. Here they are asking how the desorption equilibrium pressure and adsorption equilibrium pressure are related. Which one is higher, adsorption equilibrium pressure or desorption equilibrium pressure in an adsorption hysteresis? We know that the desorption equilibrium pressure is always lower than the adsorption equilibrium pressure in a hysteresis, adsorption hysteresis. So option A is correct. When adsorption hysteresis is observed, the desorption equilibrium pressure is always lower than the obtained by adsorption. So here we can see a adsorption hysteresis where the amount of adsorbate adsorbed per kilogram of adsorbent is on the y-axis, and in the x-axis the relative pressure is given, that is P by P0. So the adsorption will be first going through this path, then on decreasing the pressure we will get the desorption peak. So this is the desorption branch. So we know that from this graph we can see that the desorption equilibrium pressure is always lesser than the adsorption equilibrium pressure. So the option A is the correct answer. Let's move to question number 6. Which one of following statements is true for capillary condensation? 4 options are given. Monolayer adsorption with adsorbate condensing inside pores, heat of adsorption very much greater than heat of condensation. Condensation inside the pores occurs above dew point of bulk fluid. Option D, all of the above. So what is the characteristic of capillary condensation? So we know that in capillary condensation a multilayer adsorption with adsorbate condensing inside the pores happen, but in option A it is given monolayer adsorption with adsorbate condensing inside pores. So option A is incorrect. And also in capillary condensation the heat of adsorption is nearly close to heat of condensation. So option B is also incorrect. And in option C, condensation inside pores occurs above dew point of bulk fluid. Option C is correct for capillary condensation. In a capillary condensation inside the pores occur above dew point of bulk fluid. So the answer for question 6 is C. Capillary condensation is characterized by these 3 points, like multilayer adsorption with adsorbate condensing inside pores, and heat of adsorption is close to heat of condensation, then condensation inside pores occurs above dew point of bulk fluid. Let's move to question number 7. During design of bubble cap tray, the number of caps on a tray is decided based on. So the design of a bubble cap tray, what are the factors that is used to determine number of caps on a tray? Four options are given: tray spacing, allowable gas velocity through the slot, diameter of column, liquid velocity on the tray. So tray spacing and diameter of column are not considered for designing the number of caps on a tray. Mainly the factor which is affected used for calculating the number of caps in a tray is allowable gas velocity through the slot. So option B is the correct answer. The allowable gas velocity is used for determining the number of caps on tray for a bubble cap tray. So let's move to question number 8. Match column 1 with column 2. In column 1 some processes are given, and column 2 corresponding characteristics are given. Main processes are pressure swing adsorption, temperature swing adsorption, vacuum swing adsorption, displacement fluid technique. And the characteristics are applicable for both gas and liquid. Desorbate recovery is of low purity. Option C, isothermal process. Option D, operates close to ambient temperature. So let's see first what is about pressure swing adsorption. Pressure swing adsorption is only applicable for gas, so option A is incorrect, and the option B, let's see, pressure swing adsorption, desorbate recovery is of low purity. The purity of the desorbate in the pressure swing adsorption is high, and it is not isothermal process. Pressure swing adsorption is not isothermal. Option D, operates close to ambient temperature. Pressure swing adsorption operates close to ambient temperature. So 1 is matching with D. So the option will be option B only. So let's see other things whether it is matching or not. 2A, temperature swing adsorption. Temperature swing adsorption is applicable for both gas and liquid. And 3 is B, vacuum swing adsorption is used. Vacuum swing adsorption is after vacuum swing adsorption, the desorbate recovery is of low purity, and displacement fluid technique is a isothermal process. So option B is correct. A pressure swing adsorption is operating at ambient temperature, and temperature swing adsorption is applicable for both gases and liquid. Vacuum swing adsorption is used where the purity required is low, and a displacement fluid technique, isothermal process, is observed. So question number 9. Which of following is a correct statement? During channeling in packed beds, the liquid tend to move towards the tower wall. Option B, distributor above the packed bed is for gathering the gas leaving the bed top. Option C, chimney trays are used for introducing feed in packed towers. Option D, packed tower diameter is decided based on minimum wetting rate, meter cube per hour per meter square packing surface of packing being used. So we are asked to find which one is the correct statement. uh, Option A, let's see. During channeling in packed bed, the liquid tends to move towards the tower wall. It's a correct option. During channeling, the liquid tends to move towards tower wall, and distributor above the packed bed is for gathering the gas leaving the bed top. It's a wrong option because distributor above the packed bed is used for achieving uniform distribution of liquid. Option C, chimney trays are used for introducing feed in packed beds towers. Chimney trays are used for drawing side stream in packed towers as well as in tray towers. This about chimney tray we have discussed in week 4 assignment questions. And packed tower diameter is decided based on minimum wetting rate of the packing being used. But using minimum wetting rate shall lead to maximum tower diameter, but the diameter is based on flooding and keeping wetting rate to be above minimum wetting rate. So the packed tower diameter is determined based on flooding consideration and keeping the wetting rate above minimum wetting rate. Which of following are the characteristic features of chemisorption? Low enthalpy of adsorption, associated with monolayer adsorption, reversible. BET isotherm is used to predict equilibrium adsorption. So we are asked to find the characteristic features of chemisorption. So there are some characteristic features like chemisorptions have high enthalpy of adsorption, but here it is written chemisorption low enthalpy of adsorption. So one is incorrect. So option B, option C and option A are incorrect. So we know that option D will be the correct answer. And let's see, chemisorption is associated with monolayer adsorption. Generally the chemisorption is associated with monolayer adsorption, and here option 3 it is chemisorption is reversible. Option 3 chemisorption is reversible is incorrect. Chemisorption is irreversible. And option 4 BET isotherm is used to predict equilibrium adsorption. Chemisorption involves the usage of Langmuir isotherm to model equilibrium. So option 4 is also incorrect. So the correct answer for this question will be option D. Let's see what are the characteristic features of chemisorption. Chemisorption involves high enthalpy of adsorption. Generally monolayer adsorption is seen in chemisorption, and chemisorption is irreversible in nature, and Langmuir isotherm is used to model equilibrium. So thank you for listening to this lecture.